Okay, ladies and gentlemen, we're at 5.3, which is finding the solutions to Quadratics notes. So our goal here is to solve by finding the values of x so we can determine the zeros or intercepts or solutions. This means we're looking for where our graph would cross the x-axis. So there are some possibilities for the number of zeros. First, you could have no zeros. So we could have a graph, and I'm going to draw one here. So there's a parabola that does not touch the x-axis. So it's going to have no zeros. We could have one down here too, or over here. Moving over, you could have 1 0. So that just means it's going to touch the x-axis one time here, or maybe here, or over here. Let me make sure I have my arrows on each. And then lastly, we could have where our parabola touches the x-axis twice. So maybe here or like that. And we're going to look for different methods for finding the zeros. So there are 3 methods we're going to look at in order to solve quadratics. So factoring, we're going to use factoring when the graph is in factored form, which is also called intercept form. Or using square roots. We're going to do that for vertex form. And the distance from the axis, this is actually the quadratic formula. And we're going to use that for standard / general form. So we're going to try some problems. For each of them, after we find the zeros, I also want you to find the coordinates of the vertex, tell if the graph opens up or down, and sketch a graph. So if we're going to find the zeros of x plus 8 in parentheses times x plus 2 equals 0. First, this is in factored form. So using the zero product property, I set x plus 8 equal to 0 and x plus 2 equal to 0. Then here, I just solve this equation, subtracting 8 from both sides. And we get x equals -8. Minusing 2 here, we get x equals -2. So my 2 zeros are at -8 and -2. So now to find the vertex, we could certainly multiply this out, put it into general form, and complete the square. But an easier way is to average the 2 zeros. So what we're going to do is find the average of -8 plus -2. And to do that, I just add them together and then divide by 2. So that gives me -10 over 2, which gives me -5. So the x-coordinate of the vertex is -5. So that tells me the x-coordinate of the vertex is -5. And then what I do is substitute into this function. Remember, instead of 0, we can substitute in y. So to find y, what we do is we take our function, and I'm going to substitute -5 in. So -5 plus 8 times -5 plus 2. And then that's going to equal our y-coordinate of the vertex. So -5 plus 8 is 3. And then negative 5 plus 2 is negative 3. And 3 times negative 3 is going to give me negative 9 for y. So our vertex is at negative 5, negative 9. And then to sketch a graph of that, I'm just going to go over here, negative 5, negative 9, and just put a dot. We don't have to be too precise. And then I know it's going to cross over here. I'm just going to say this is negative 8. This is negative 2. And sketch that. And then we can see that this graph opens up. So now if we're finding the solutions of x squared plus 4x plus 21, we have some options. We can for sure use the quadratic formula. And we're going to practice that. So we can say a equals 1 because there's 1x squared. B equals 4 because the coefficient in front of x is 4. And C equals negative 21. In writing the quadratic formula, we know that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So substituting those values, the opposite of 4 is negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 21 all over 2 times 1. So we're going to substitute that further. 4 squared is 16. Minus 4 times 1 times 21. So I'm just going to compute all of that directly with a calculator. And that is 100. So the discriminant is 100. And then I can divide that by 2. In doing that, the square root of 100 is 10. So we have x equals negative 4 plus 10 over 2. And then I'm going to split that and go x equals negative 4 minus 10 over 2. So this is going to simplify. Negative 4 plus 10 is 6 over 2, which gives us x is equal to 3. And then for our second root, negative 4 minus 10 is negative 14 over 2, which gives us negative 7. So our other root is x equals negative 7. So that's one option. Now to find the vertex, actually, with the quadratic formula, this negative b over 2a is actually the x coordinate of the vertex. So x is going to equal negative b over 2a. So that's the x coordinate of the vertex. So substituting that in, we have negative 4 over 2 times 1. So negative 4 over 2, which is negative 2. And then to find the y-coordinate of the vertex, we just plug into the function. So to find y equals, we need to do negative 2 squared. I put that in parentheses because we need negative 2 times negative 2, plus 4 times negative 2, minus 21. So computing that gives us 4 minus 8 minus 21. So I'm going to use a calculator, 4 minus 8 minus 21, and I got negative 25. So to just quickly sketch that graph, I'm going to put this over here. Negative 2, negative 25 is going to be down here in the third quadrant. I'm just going to label it. And then our roots are 3. So I'm going to put over here, x equals 3. And then I'm going to put here, x equals -7. Draw my parabola, and we can see it opens up. So now, the x-intercepts, we can see that this is vertex form. We can actually solve this using square roots. So what I'm going to do is divide both sides of the equation by 3 first. And we have, this would be 1. So m minus 4 squared equals 12 over 3 is 4. Now I'm going to take the square root of both sides. And when I take the square root of 4, we have to remember I'm going to get plus or minus 4 because 2 times 2 is 4 and -2 times -2 is 4. So we would get m minus 4 equals plus or minus 2. So we're going to split that up and say m minus 4 equals 2 and m minus 4 equals -2. So then adding 4 to both sides, we get m equals 6. Adding 4 to both sides here. What I do is I just imagine this is 4 minus 2, and I get m equals 2. Now this is in vertex form. So remember in vertex form, when this is going to be h. So this is the x coordinate of the vertex when you do y equals a times x minus h squared, and then plus k. We're going to have to move the 12 over to get it on the same side. So if I manipulate the equation a bit, we could say this would be y equals 3 times m minus 4 squared minus 12. So we can say that for our vertex, h equals 4 and k equals -12. So to just rewrite this again, because it's a little sloppy, y equals 3 times m minus 4 squared minus 12. So h is -4, or h is +4, and k is -12. Now to sketch that graph, we would go over 4, down 12. So I'm just going to label the point for -12. Our roots are 6 and 2. So there's 2 and 6. And we can see that it opens up. So to look at this equation, I'm actually adding 1. So to find the vertex, since it's in vertex form, we can start there. Since I'm adding 1, the vertex is -1 for x, and then k is -6. Now we're going to solve this. So if I'm solving, y equals 2 times x plus 1 squared minus 6. Remember, we want when y equals 0 for the zeros. So we say 0 equals 2 times x plus 1 squared minus 6. So we need to move the 6 over the other side by adding 6. And 0 plus 6 is 6. So 6 equals 2 times x plus 1 squared. I want the x by itself, so I need to get rid of this 2. I'm multiplying, so the inverse would tell us to divide by 2. And then 6 divided by 2 is 3. So 3 equals x plus 1 squared. Taking my square root. Remember, when I take a square root, we have the positive or negative. So I'm going to switch sides here and say that x plus 1 equals plus or minus the square root of 3. So now what I'm going to do is break that up into 2 equations and say x plus 1 equals the positive square root of 3. And I can leave that positive off. or x plus 1 equals the negative square root of 3. Subtracting 1 from both sides, I would say x equals negative 1, and then I add on the square root of 3. And then here I subtract 1 again, and we would say x equals negative 1 minus, and I wrote the square root of x, sorry, that's the square root of 3, minus the square root of 3. I'm going to leave those. We could approximate those and then graph that, but for the sake of time, we're just going to move over to the quadratic formula. So here, again, I already previewed that for you. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then just a reminder, the negative b over 2a is our x coordinate of the vertex. And again, if we wanted y, we could plug negative b over 2a into the quadratic formula in standard form and solve. And then here, b squared minus 4ac is my discriminant. And there's some possibilities. If b squared minus 4ac is greater than 0, we have two zeros. If b squared minus 4ac equals 0, we have 1 0. And we're going to learn in our Algebra 2 that if b squared minus 4ac is less than 0, you can't take the square root of a negative. There are no real solutions. But we're going to look at imaginary numbers tomorrow or on Monday. So here we're going to use quadratic formula to solve. So what we're going to do is subtract and get everything on the same side. So to move the 5x over, I'm going to say x squared minus 5x. And then I'm going to add the 1, so plus 1 equals 0. We know that a equals 1, b equals negative 5, and c equals 1. So substituting into our quadratic formula, x equals the opposite of negative 5 is 5 plus or minus the square root of negative 5 squared minus 4 times 1 all over 2 times 1. So in substituting this, we have x equals, just going to use my calculator to simplify the discriminant. So negative 5 squared minus 4 times 1 times 1 is just 4. So it's 21. So we have 5 plus or minus the square root of 21 over 2. We can break that up into its two parts. So x equals 5 plus the square root of 21 over 2, and x equals 5 minus the square root of 21 over 2. Example 2, we do the exact same thing. So I'm going to subtract the 5x. So we have on the left side of the equation 3x squared and then minus 5x. I'm going to minus the 8 over as well. So minus 8 equals 0. I always identify my coefficients. So a equals 3, b equals negative 5, c equals negative 8. And then I substitute those into the quadratic formula up here so that I know x equals the opposite of negative 5 is 5 plus or minus the square root of negative 5 squared. I'm just going to simplify that directly. That's 25. And then plus 4 times 3 times negative 8. And then divided by 2 times 3. So x equals 5. And then I'm going to simplify here. Oh, and I forgot this should be a minus here. So didn't want to make that mistake. So simplifying, we go 25 for the discriminant minus 4 times 3 times negative 8. I get 121. So 5 plus or minus the square root of 121 over 2 times 3 is 6. So simplifying that further, x equals 5 plus or minus square root of 121 is 11 over 6. So I'm going to break that up into its two parts. X equals 5 plus 11 over 6, and x equals 5 minus 11 over 6. 5 plus 11 is 16 over 6, which we can reduce to 8 over 3. So that's one answer, and we could put that as from the improper fraction to a mixed number as well. And then 5 minus 11 gives us negative 6 over 6, which equals negative 1. So our two roots are x equals 8 over 3 and x equals negative 1. And looking at our last problem, we're going to write the quadratic equation that was used to get the solution to x equals negative 4 plus or minus the square root of 16 minus 4 times negative 2 times 10. In looking at this, I know that negative b equals negative 4. So I can conclude that b equals 4. And then here it's minus 4 times a. So I can conclude that a equals negative 2. And then here is c, so that we can say c equals 10. Putting that into our equation, y equals, again, general form or standard form is ax squared plus bx plus c. Substituting in our numbers, we get y equals negative 2x squared minus, or plus 4x. B was positive 4, and then plus 10. And then lastly, what I'm going to show you is where did the quadratic formula come from? So first of all, we have the general quadratic formula, ax squared plus bx plus c equals 0. And it came from actually completing the square. So what I'm going to do first is move the c over to the other side by subtracting it. So we have ax squared plus bx equals negative c. Then what I'm going to do is factor out the a. So we can go a times x squared plus b over a times x. And then what I'm going to do is take some side work here and take b over a and then divide that by 2. So b over a divided by 2 is the same as multiplying by half. So that's b over 2a. And then remember, we square that. So b over 2a squared is going to give me b squared over 2a squared. I'd square the 2. So I'm going to get 4 and then a squared. So I'm actually going to add that to both sides of my equation. So I'm going to add b squared over 4a squared. And then we're going to have negative c plus b squared over 4a squared. And then just a reminder here, when I added b squared over 4a squared, I multiplied by a here. So for this one, when I multiplied that by a on this side, I actually have to have an a here as well. So this is going to factor into a times x plus b over 2a squared. And then over here, I can actually cancel out an a. And then we would have negative c plus b squared over 4a. I'm going to do some work here. So I'm going to find the common denominator. So I'm going to multiply by 4a over 4a. So then what we can see is if I do a little algebra up here, I'm going to put this term first. So we have b squared. And then if you notice here, I can put those in alphabetical order and put minus 4ac. And then we have over 4a. So I'm going to simplify that further. A equals x plus b over 2a squared equals b squared minus 4ac all over 4a. Now to get rid of this a, I'm going to multiply both sides by 1 over a. So 1 over a times x plus b over 2a squared equals 1 over a times b squared minus 4ac times 4a. So that'll cancel. And we have x plus b over 2a squared. Multiplying here, that's just going to give me b squared minus 4ac all over 4a squared. And now we're ready to take the square root. So we have x plus b over 2a equals, I'm going to take the square root of the numerator. So the square root of b squared minus 4ac. And then remember, we do our plus or minus. I'm going to keep that in the numerator. And then the square root of 4a squared. So before I subtract this over, we have x plus b over 2a equals plus or minus the square root of b squared minus 4ac in the numerator. In the denominator, the square root of 4 is 2, and the square root of a squared is a. And now I'm going to get x by itself. So x equals, I'm going to subtract b over 2a from both sides, so that just moves over here. So negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. These have a common denominator, so we see that x equals negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. So we see that the quadratic formula came from completing the square.